Welcome to the webinar hosted by Regardis and Measurlabs. My name is Stano Gajdos. This webinar is titled Stay Ahead of the PFAS Curve. Now, we were going to overview regulations and analytical methods and related challenges to PFAS. So what you are going to get from this webinar, this webinar is being recorded. The recording then will be publicly available on our YouTube, so you can come back to it anytime you'd like. You can also later check the presentation slides from the speakers. And based on the Q&As and the related discussions, we will be preparing a Q&A sheet sending out to participants with a larger overview of the topics. There is also a follow-up webinar, which I'll link and invite to at the end of this one. This is going to happen in 2 weeks, and we will be looking more into practical details of the problematic. Now, a few house rules. I already saw a question popped up in chat about receiving presentations. So yes, you're gonna receive the presentation slides. And then for the discussion or for the outline of the webinar, first, I'll introduce it. Then speakers will take place, talk about the regulations and analyticals. Once this is done, or during this being done, you can post your questions into the Q&A interface in Zoom. You can also post them in chat, but I'm not sure, given the amount of people here, we will be able to get to them all, even maybe in the Q&As. But what I would like, or we would like to prioritize, is actual discussion. So whenever you feel like talking in the discussion part of the webinar, so the second half, please raise your hand. I will allow you to turn on the microphone, and then you can ask live. So live questions will be prioritized over the Q&A ones, and then we also have some questions from the registrations. In the past, we also held multiple webinars on the new CLP hazard classes. I know many of you here are more analytical than regulatory, but I am sure that some of these will be relevant to you as well. We are now representing Regardis, which is a chemical regulatory consultancy firm located in Czech Republic, but we work all across Europe and practically the world as well. Feel free to reach out to us if you need any chemical management or chemical regulatory related help or services. Now it's my turn to turn the mic to the speakers. I would like to introduce Mary Rantanen, Lucia Havelkova, and Jana Trubisina, who are here in the call with us. Lucia will talk first from the point of chemical regulations in Europe. So Lucia is the regulatory specialist at Regardis. She has the most background in polymers and REACH regulations, and she'll share her view on the PFAS in a second. So Lucia, the floor is yours. Welcome.
So thank you for the introduction. Good morning, everyone. My name is Lucia Havelkova, and as announced, I will talk about PFAS regulation in EU. Although I'm almost sure that most of you have heard about PFAS before, I would like to first introduce these substances a bit just to, get us on the same page. But later I will focus mostly on the regulations, especially on the background and current status of PFAS universal restriction proposal. PFAS are a large and extremely diverse group of chemicals with many different physical-chemical properties. But what all these substances have in common is that their chemical structure is based on fully or partially fluorinated carbon chains, which are connected to different, usually polar functional groups. Thanks to their amphiphilic structure, it means that their molecules have both a hydrophilic and hydrophobic part, and thanks to the extreme stability of carbon-fluorine bond, PFAS possess really unique and desirable properties for many uses. For example, they are stable under intense heat. Many of them are used as surfactants or as water-repelling agents. So the many industry major industry sectors are using PFAS, aerospace, construction, food contact materials, textiles, you simply name it. And according to ECHA, there are 230,000 tons of PFAS placed on the market every year. And taking into account that PFAS are on the market since 1940s, it's really hard to imagine the amount of PFAS which is now in our environment. PFAS could be emitted in the environment during their whole life cycle. It means during the production of the chemical itself, but also later during the product manufacture, especially during the product use and also during the waste stage. Besides their widespread use and high manufacture volumes, there are severe concerns about their harmful effects on human health and the environment. The major concern is their persistence. It means that they are really hard to break down and they stay in the soil and water for decades, even centuries. And we as humans or as organisms in general are exposed to PFAS through drinking water or through food consumption, and PFAS tend to accumulate in our bodies, in organisms, and also in the environment, and causing several toxic effects. They could be toxic for reproduction, or some of them are suspected of causing cancer and so on. Those are all the reasons why PFAS are on a spotlight of regulatory authorities for years. Several individual PFAS are already restricted globally under Stockholm's Convention. This convention is implemented in EU legislation via so-called POPs regulation. POPs refers to persistent organic pollutants. Several individual PFAS are already regulated under REACH regulation. I mean, in the European Union. From this table, you can see that several individuals are restricted or are identified as SVHC substances. But the thing is that if we continue to regulate them with this single molecule approach, it would take a really long time to manage or to regulate them all. And I would say this is one of the triggers why there is this wide range, or if you want, universal restriction proposal now on the table of European Union, aiming to restrict manufacture, placing on the market, and use of PFAS. This was submitted by authorities of Germany, Netherlands, Sweden, Norway, and Denmark. And the proposal is using a grouping approach, which is based on the fact that all members of the PFAS group share a common hazards and risks, which results from their persistent perfluorinated parts of their molecules. The key hazardous properties of PFAS named in the proposal is their persistence, either the persistence of their own, but also the persistence of their terminal degradation products, sometimes called as PFAS arrowheads. But also other properties are considered, for example, their long-range transport potential or their possible endocrine activity. For the purpose of this restriction proposal, PFAS included in the restriction are defined as substances that contain at least one fully fluorinated methyl or methylene carbon atom. And you could probably feel that this is quite a broad definition, which will cover a really long list of chemicals. There are two options in the proposed restriction, how the actual restriction could look like in the future. The first option is a full ban, and the second option is a still full ban, but with some time-limited derogations. And the length of the transition periods for specific uses will be based on the availability of alternative for this specific use, or on and also on socioeconomic considerations. So now let's have a look at the timeline, what has already happened and what is like happening at the moment with the proposal. It all began in January 2023 when the proposal was submitted. And then there was this 6 months open public consultation during which all interested parties could join and could share their comments or share any evidence they have on PFAS. And during this time, ECHA has received an unprecedented and really huge number of comments, more than 5,000 comments. So basically, what is happening now is that ECHA committees, RAC and SAC, are still in the process of evaluating the proposal itself, given its huge scope, but they also need to evaluate all the received comments or the received evidence and somehow incorporate them in the background document. What they have already done during their meetings in 2024, they have provisionally concluded on the scope of the proposal and that the primary concern of PFAS is indeed their persistence. And they have already concluded on so far 8 industry sectors which could be impacted, like consumer mixtures, cosmetics, textile, or food contact materials. Well, yeah, at this point, I really want to once again repeat and maybe by this way emphasize that the conclusions agreed at the committee's meetings are only provisional. And unfortunately, they are not available to the public until the final until they finalize the evaluation of entire restriction proposal and until they adopt their opinions. Nevertheless, thanks to the inputs from the consultations, the information on PFAS are still improving. For example, thanks to those comments, it did help them to identify new uses which were not specifically named in the restriction dossier, in the initial restriction dossier. And also now it seems that alternative restriction options, it means restriction options other than ban, are being considered for certain uses or certain sectors, as for example, batteries and fuel cells, where the received evidence suggests that total ban could lead to severe socioeconomic impacts. During their meetings this year, the first meeting is held in March. They will discuss other sectors as fluorinated gases, transport and energy, and other sectors will follow. Here are prepared some links for documents, for some essential documents, or some links I hope you will find useful. And with this, I would like to thank you for your attention, and I will pass word to my colleague Jana, who will tell you about PFAS regulation in regions outside European Union. So Jana, I will stop sharing and floor is yours.
Thank you. Thank you very much, Lucia. My presentation in this webinar is going to be rather short, so I tried to pick some important deadlines and important information. And what we are going to talk about is the PFAS reporting requirements in USA and in Canada. Of course, in other world, there are also some new news about PFAS, but in this webinar, I will just cover these two parts. So let's start with United States. The reporting in United States is done to the European Protection Agency, Environmental Protection Agency, or EPA, and all PFAS that were identified in articles which were manufactured or imported into the US from January 1st, 2011 to December 31, 2022. So since now it's already 2025, of course, it's logical that this data collection is ongoing. So both countries, US and Canada, are now in the process of collecting the data and checking what is the quantity, what is the amount, what are the uses of PFAS. What should be reported? There should be reported the information on PFAS uses, the production volumes, disposal, exposure, and hazards to be submitted to EPA. The thing that is not clear for now still is how the reporting will look like, because there is still no available template for reporting and the database is still not opened yet. The reporting deadline has been changed to July 2025, and the new deadline is now 2026, also July. And also there is a thing that I wanted to mention is the definition on PFAS, as Lucia was mentioning. It is very broad sometimes, and for an EPA, for Environmental Protection Agency of United States, there is a list of PFAS that is available on their website. However, any substance that is listed is in TSCA, in Toxic Substance Control Act, and that meets the structural definition of PFAS should be reported. Also, some substances will not meet this definition of a chemical substance under the TSCA, and they are not reportable. The important thing that the companies should do in US is to show that they have performed the due diligence. So the information that they need to report is the information that is reasonably accessible. So it means that they need to show that they have done everything they could to collect the data on PFAS. In Canada, it is a bit more easy with the definition, because there is a list of 312 substances, and also list of applications and of the functional codes of the substances. So it makes it really easier to identify whether or not your substance is is reportable. And what information should be collected? So far, it's only 2023, but of course, since it's 2025 now, you can just keep collecting the data. So the deadline was in 29th of January 2025, so almost a month ago. However, many companies were granted a 6-month extension that they could request, and after the deadline, probably the companies will not get the extension, but you still can submit the information if you haven't met the deadline. The information that should be collected is import, manufacture, and use. So even if you haven't manufactured or imported anything, and you have just bought, being a company in Canada, you just bought something containing PFAS substance in Canada, you still might need to report the use of the substance. Also, there are 3 options to report. First is SEPA Section 71 response. This is basically when you meet the criteria of reporting. Here on this slide, you can see the link responding to the PFAS notice, where you can also find the official document that needs to be filled. The second option is declaration on stakeholder interest. If you do not meet the reporting criteria, but you still want to share some information to with the government of Canada, you may submit some additional information that you might have. And also there is a declaration on non-engagement. It is when you do not meet the criteria and you just want to inform about that the government. So I really tried to collect just the important deadlines and things that you need to do. But in case you're interested in PFAS in US and Canada, you can contact me with your questions or contact my colleagues. We're also always happy to respond or to have some discussion. Thank you.
Okay, thank you, Lucy and Diana, for your presentations and for talks. I would like now to follow up with Meri Rantanen, the testing expert from Measurlabs. So Meri, the floor is yours.
Thank you for the introduction. Let's hop to the section where we are discussing actual analysis of PFAS compounds and what are the challenges and recommended approaches with the analysis. First, I want to say a couple of words about me and our company. I'm Meri Rantanen and I'm chemist from my background. I have now been working at Measurlabs 1.5 years and I work as a testing expert here. I handle most of our PFAS project at the moment, and because I'm also a part of our chemicals and environmental team, I handle also a lot of projects related to the elements and ions and environmental samples, chemicals, different waste materials, and samples from different industries. Okay. Then a couple of words about Measurlabs. We are a new kind of laboratory testing service provider. We have combined analysis from over 900 labs, and we sell and arrange analysis for our clients. We have 6 different teams of experts, and we are trying to help with all kinds of samples and testing needs. For example, for PFAS compounds, we have almost 20 labs in our network, which we are used almost weekly, and for that reason we are able to help with different kind of needs, for example for legislation purposes or R&D, or if our clients want to check if their samples contains PFAS or not. Okay, let's start with the challenges. As you might know, there are thousands of PFAS compounds in this world, so analyzing all of them in the one analysis is not possible at the moment. This analytical field is still in early stage, which means that legislation is developing constantly and analytical methods are developing constantly, and it's a bit challenging to stay on top of all the updates what are currently happening. And then one really big issue that there is still lack of harmonized methods and standards, which means that laboratories have a little bit different analysis packages available and a little bit different detection limits that can be achieved and a little bit different pre-treatments for the samples. And all of these challenges may cause a question that which method and what approach we should select for our samples. So how we can then tackle the challenges? Because PFAS compounds always include fluorine, we can analyze also total organic fluorine or total organic fluorine. And that can be used to estimate if the PFAS is present, even we don't actually analyze the individual PFAS compounds. Then we can investigate your samples with top s.r.o analysis, which can be used if you want to check if your sample includes precursors of PFAS compounds. that can be actually transferred to stable PFAS compounds in certain conditions, for example, in an environment. And currently the best practice and most used is to analyze total fluorine or total organic fluorine and targeted PFAS compounds. So how we can then choose the method and standard for our samples? Let's start with the fluorine analysis. Basically, there are two different ways of analyze fluorine. We can analyze total fluorine, which is the simplest way, and then we can determine total organic fluorine. Total fluorine can be analyzed straight from the samples, and total organic fluorine can be calculated from the results of total fluorine and inorganic fluorine. For some well-known materials, inorganic fluorine can be assumed negligible, and in these cases, total fluorine and total organic fluorine are same or at least very close to each other. And this can also be happening if the results of inorganic fluorine is so small that analytical method can't detect that. And for that reason, some laboratories may also have the analysis available called total organic fluorine analyzed as total fluorine. Typical methods for fluorine analysis is combustion ion chromatography, oxygen bomb digestion plus IC analysis, and for inorganic fluorine, the most used method is extraction plus IC, or if the sample is suitable, we can use only the IC method. Applications for fluorine analysis are extractable organic fluorine, which can be done to solid samples and first extract those, then analyze fluorine. And then the second application is adsorbable organic fluorine, which can be used, for example, for water samples. I wanted to add some challenges with total fluorine and total organic fluorine to this slide. Typically, the detection limits in fluorine analysis are a bit higher than in targeted PFAS analysis. So if the samples contain really small quantities of PFAS compounds, we might not be able to see those in fluorine analysis. And also in some applications, short-chain PFAS compounds can be lost. So we definitely should choose the method wisely and detect the limitation of the methods that we are using. Let's move to the targeted PFAS. The most commonly used method is liquid chromatography combined to mass spectroscopy. Usually labs use HPLC-MS-MS or UPLC-MS-MS techniques. These methods are suitable for many sample types, and high-performance methods are used especially with challenging matrices. The limitation or challenge with LC-MS method is that the technology of the instrument is highly affecting to the detection limit. Also, the pre-treatment of the sample is highly affecting to the detection limit. And I have listed some typical detection limits to this table, and as you can see, the ranges are quite wide. So choosing the right method is it's really important, and it should be always checked that the method is capable for the detection limit that we want to achieve. Second method for targeted PFAS compounds is gas chromatography combined to mass spectroscopy. And with that technique, we can determine volatile PFAS compounds. This technique gives us really good information in addition to LC-MS methods, but unfortunately, most of the laboratories currently have only LC-MS method available for PFAS compounds, so it might be a bit difficult to find GC-MS method for volatile PFAS compounds. Okay, let's move to the section when we are actually analyzing the samples and what we should expect from the results. Both targeted PFAS analysis and fluorine analysis give us numerical values, and usually our clients wish that the concentrations are small and in some cases the concentration might be so small that it's below the detection limit of the analytical method. And in those cases, the result can be reported under LOQ or LOD. And the other option is to report the result like not detected. Nowadays, most of the laboratories use also CAS numbers when reporting the results. Sometimes short names of the compounds and long names of the compounds are not used in line, which can cause confusion. And it's always good to add CAS numbers to the test report, because in that way we can actually know what compounds have been included to the analysis package. Then we have listed here some commonly used analytical standards or methods, and there are already some official method standards available. I have listed here a couple of EPA standards for environmental samples and drinking water samples. Then there are SEN standards, ISO standard, and EN standard available for consumer products and firefighting foams. And then I wanted to also add one official method standard for fluorine, analyzed by combustion ion chromatography. And I want to highlight the importance of in-house methods with PFAS compounds, because there are not too many official method standards available yet. So there is a lot of in-house methods or in-house methods that are based on some analytical standard available. And those methods can be very specific and carefully developed and are suitable for special sample matrices. One good example could be that for chemical samples, it's really difficult to find official method standard for different chemicals, but we have some labs in our network that have developed methods to the chemicals, and they are really good methods if we can find the official standard. I want to highlight that the selection of the method has to be done super carefully. Different methods include different amount of compounds and different detection limits. So especially in those cases when the results are used for legislative purposes or some official monitoring, then I highly recommend you to contact lab or testing experts as soon as you are planning the analysis, so the lab or, for example, us can check that the method is actually suitable for the purpose. Then my last theory slide about the analysis is what to remember when you are preparing the samples. We have listed here some typical sample quantities that we usually request. These sample quantities are always depending on the sample matrix and method, so these should be always checked case by case. And as you might know, PFAS compounds are used almost everywhere, so the risk of contamination is really high. So all the sampling equipments and containers must be PFAS-free materials. And nowadays, the most recommended material is the PFAS-free plastic, for example, HDPE plastic. And even though we are discussing forever chemicals, for the liquid samples and environmental samples, the samples should be always stored in cold conditions so that the samples stay as stable as possible. And then summary slide. What you should remember about this presentation is that fluorine analysis combined the targeted PFAS analysis is really good choice if you want to check if your samples contain PFAS. The selection of the method is super important, and I highly recommend you to contact testing expert in early stage of the planning, because then we can check the suitability and availability of your samples. And then remember to pack your samples in PFAS-free materials, so we don't want to analyze contaminated samples. If you want to discuss later or order PFAS analysis, you can always contact me and we can discuss about your specific needs. Thank you.
Thank you, Mary, for the wonderful presentation. We are getting towards the discussion part of the webinar. I would like to kick it off with an invitation to our follow-up webinar, which will take place in 2 weeks' time. You can already register for it using the QR code on your screen or the link I am placing in chat right now. So there are many questions in the Q&A section, but there are also questions which someone wanted to ask live. I believe it was Manfred Büchel who asked, and I will share the screen again so you can see the question, because part of it was in chat, part of it was in Q&A. And also Manfred wanted to talk as well. So yeah, the screen should be shared, but Manfred asked, PTFE is used in any engineering thermoplastics for additive as mold, PTFE powder and or derivatives for demolding. Further, sealing industry is a big application field Manfred is in since 35 years. He's wondering what material substitutions or substitutors industry is working on. Discussion welcome. Manfred, if you'd like, I can allow you to talk now if you want to further clarify. So you can unmute yourself as well.
Yes, hello.
We can hear you. Hello.
Yeah, hello all. Yeah, look, I'm from the industry and I'm really wondering, I mean, these big amounts of PFA discussions, 250,000 of tons each year. I mean, so that's very outstanding, big amounts, A1. And A2, as I written, I'm 35 industry years down the drain on B2B applications, aerospace, I had it all. I mean, so Green Tweed, all these kind of makers, Polypenko, I worked for. And if you go back to the engineering plastics, let's say arena, which is one of the biggest market using fluor as a, I would say, either an unused material like the old PTFE powder I was working with, like hooks and so, but it's going on the PVDAs nowadays, which you can injection mold, which is still a fluor derivative for the usage of into chemicals for H2SO4 acids and all these kind of things. Like food, they have it all as a sealing material inside. You know, and that's one point. The second is what I've written is the engineering and thermoplastics market, which inverts ABS, polystyrene, etc., polycarbonate, and so they have a 0.2 or 0.115% of PTFE powder or equivalent derivatives as a let's say additive inside the entire polymer compound, which helps to demold in the injection molding process during extrusion, etc., etc. That's what I've written. I mean, so I'm really wondering what is really going on with the big industry. I mean, so talking Savage, Bayer, and so and so and so. What is there happening that they try to eliminate the fluor type as a demolder or an actual helping additive in that? I remember I did stuff like that, starting using waxes on ABS, acryl butadiene styrene instead of PTFE, but just formally for the cost reasons with a computer company. But, you know, that's quite interesting for me, and I like really to understand. And that's point one. Point two is really the people coming to me as an expert in engineering thermoplastic and talking to me about this subject. There are projects out there, but I think this is offline to discuss later on by a phone call. I've written that. But this is, I like really from you guys to learn what's clocking on the industry, what the big guns are doing.
Thank you for the question, Manfred. I understand this is a very industry-specific question.
Yeah.
I am not sure if regulatory experts or analysis experts will have the answer for you at the moment, or at least right away. I see Lucy
Yeah, I
unmuted herself.
maybe will try to just shortly comment. Well,
Yeah.
as Steno said, well, this is more like engineering and like for really industry involved people question, because you were asking what if there is any like specific substitution for those materials and so on. I will maybe just shortly comment in a way that all these comments from the industry hopefully were raised during the consultation period. And well, fluoropolymers and like fluor elastomers and other kinds of these are really on the highest interest for all the stakeholders, and it was really a frequent question during all the ECA webinars. So and all the answers from the ECA I have read were in a sense that they are really try to assess these materials in a life cycle, in their life cycle perspective. So they need to like consider whether the derogations for these selected use are on the spot. They need to if, for example, if there is likely to be some derogation for these materials, it will depend if any alternative is foreseeable. And as I mentioned in my presentation, this is all just, from my side, this is all just speculations. We don't
I see.
know like anything specific yet, since all the comments the comments are visible on and they are open to public on ECA, but their decisions of the ECA committees are not available yet. So yeah, I realized that I really did not answer probably the specific question you asked, but this is the it I can get you from the regulatory points of view.
Lucy,
Yes.
thanks very much. I think that gives, first of all, a type of your company function and your observation and activities in the market. A1, A2 is, I think that's one big topic I discuss right here, which is for me to be interesting to learn at this moment, where do we stand? That means where is the food industry standing, for example, or the pharma? Can they still continue right now, and how long? And what is happening in this past ago? You shown this schedule and timing screen before to me, and I'm wondering, maybe you can explain, Lucy, where do we stand right now, this second? What's happening in the next step? Where is the, you are observing, you're measuring, yes, but what is really the next step and when?
Well, I would say that now we are all waiting. We are all waiting on how the meetings will evolve, and we have something to. The only thing we can work with right now is the proposal from the 2023, where of course there are some preliminary or some proposed specific time derogation for specific use. You could sure like look at it, but I would be really careful or like cautioned about to really do some decisions based on that, because this is still like speculation. This is just the proposal.
Clearly understood and agreed. I mean, just for me, it's now because companies asking on me due to my polymer experience in the application field and engineering experience I got. They're talking to me and say, hey, what's going on? And what they decide for this moment is same like I'm thinking, Eunice thinking, is that they are, maneuver to to stack up where these kind of PFAS are used, step one, to see in the machine sealing, and so which kind of application could there be an idea, should there be an idea for another alternative material at this moment? Yes, no, if so, why, and so on. So I mean, that is what I'm facing. Again, I just written to, if you feel free to contact me so we can have a chat offline. That's my, my proposal to you. First one, to get connected. Second one is to exchange what's going on. And third one, to see, okay, where can we help as a team into those specific questions across Europe or US.
Okay, thank you, Manfred. I'm very sorry to interrupt this discussion. I'm sure it's fruitful, but we would like to touch upon more topics as well. We'll get in touch with you then to discuss further. I already saw your contact information in chat.
No problem. I have to hang out. I got the next meeting right now in Switzerland. Appreciate stay in touch. Have a lovely day. It was very good, and stay in touch. Be invited. Okay, thank you very much. Sorry. Bye-bye.
Bye.
Goodbye. Okay. Thank you very much. If there's any other live questions, feel free to raise your hands while preparing questions. Meanwhile, I would like to follow up with questions from the registrations, which we found very interesting, and it's asked by Marine. How do we demonstrate a PFAS-free material?
Yes, I can answer this question. As I mentioned in my presentation, there are thousands of PFAS compounds in this world, so this is actually a bit difficult to demonstrate that your samples are not including any of those. But in legislations, there are nowadays criteria about the limit values, and for example, for total fluorine or total fluorine, there might be some limit values for those, and then there are limit values for individual PFAS compounds and limit values for the sum of analyzed PFAS compounds. And if the samples meet those criteria, they might be considered as PFAS-free, even though we haven't analyzed all of the PFAS compounds that are present in this world.
Okay, thank you, Mary, for the answer. Marine, if you are in here, feel free to follow up either in chat or in Q&A if you feel like you need more information on this topic. And I would like to go to the questions asked in the Q&A, as I don't see any raised hands. Feel free to update that. And the first question asked was by Charlotte. And they're asking, what about the PFAS ban or restriction for firefighting foams? What is the timeline? I guess this is directed more towards the regulatory part. So Lucy or Yana, if you want to take the lead.
Okay. Regarding the firefighting foams, I'm quite sorry because I really I would have to dig more deep into it to say you something more specific on the timeline. The only I would just short comment on it. The firefighting foams were excluded from this universal restriction proposal, and they are handled separately. So if you are interested in this specific sector, or if you are dealing with this specific sector, it's there's a need to keep an eye on both stuffs, because sector for firefighting foams is discussed by ECHA separately. I don't know if Yana is familiar with some specific information on a restriction for firefighting foams.
Yeah, I would say that I don't have much to add to Lucia's answer, because the only thing that we need to do now is just to track the information and track the updates from ECHA.
I see. There is also a follow-up question by Charlotte asking, what the LOD, or what is the LOD you can analyze high viscosity firefighting foams in concentrates? Can you go down to 1 ppb? I feel like this is...
Yeah, 1 ppb is actually quite tight LOD for viscosity samples, but we have some specific methods available for really difficult sample matrices. So if you want to discuss this more, you can definitely send me an email and tell you more about your sample matrix. So we can definitely check if that kind of detection limit is doable.
Okay, Mary, thank you. I will stay with you for a while because there is a bundle of questions regarding Measurlabs analytics. 2 of those are asked by Monica. Is there any list of PFAS that Measurlabs is able to analyze? And what materials is Measurlabs able to analyze? And also there's a follow-up question by, I believe it was Veronica, if there is any easy method to analyze PFAS in articles. I believe some of these questions you already touched upon in your presentation, but do you want to add anything towards those at the moment?
Yes, we can definitely provide the list of PFAS when we know the sample material. As I say, we have almost 20 labs in our network, and most of the analysis packages include 20 to 50 PFAS compounds. So the list of the PFAS is definitely depending on the method and sample matrix. And then what materials we are able to analyze, almost every of these that are listed in this list, yes, the most typical matrices for us is paper, plastic, packaging materials, textiles, different chemicals, and environmental samples at the moment.
Okay, thank you. Let's move on to Tanya, asking what kind of quality level for the PFAS analysis is required in the regulatory level? Is ISO quality enough, or should there be an obeyed GMP when method is validated and analyzed? This is, I guess, borderline analytical, borderline regulatory. Anyone wants to take the lead?
Well, I can start at least. Based on my experience, because there is a lack of standardized analytical methods, there is no straight answer for this question, because sometimes, for example, in-house method can be as good as official method standard, but I'm not sure if Lucy or Jana know better about this.
Well, regarding the universal PFAS restriction proposal I was talking about, again, like all the set or the proposed concentrations are yet really provisional. So it's really hard to predict if there will be some like ISO quality needed for the analysis or so on in the future.
I see. There's an interesting question, at least for me, from like scientific point of view, from Arten, asking. Let me quickly find it. Here, asking how are short chain PFAS lost during PFAS analysis of some applications?
There are some applications where we lost the short chain PFAS because of the pre-treatment because of the nature of the analysis. I can take more information related to this if you want, but in general, this is the reason.
Okay, we are running sort of short of time. I know that the webinar is set to last an hour and a half in case, but usually people are used to running for 1 hour and then having other meetings. So if at the moment there are any live questions, we can get to those, or if there aren't, we can continue with the Q&As for a while. I would now like Mary, Lucy, Jana, if you feel any question from the Q&A section now being very interesting to you or feel like should be given priority given the topic, feel free to pick one. Meanwhile, I would like to use again one of the questions from the registrations, which will be targeted towards regulations. So Miko is asking, I'm paraphrasing here, are there exemptions to PFAS regulations and how do they work?
Okay, I will try to answer this. Regarding the exemptions, well, we can like there is already a proposed exemption for a really specific subgroup of PFAS, which are able to fully mineralize under the environmental conditions. So this could probably be extended. Again, you see that I'm using this like really careful wording because this like all really speculative. And of course, there is also other exemption from the proposal regarding the biocidal products, plant protection products, and active substances for human and veterinary medicinal products. And well, if I should touch just briefly the exemptions for specific uses for which there will be some like exemptions in a form of like time derogations. Just to be clear, won't be an extension like unlimited. It will be somehow limited by time. There will be some longer transition period, and well, I can there are more than like 20 uses or sectors which are now proposed to be somehow derogated from the restriction, and it covers really like it touches almost like any sectors, but if you are like really interested in some really specific one, I really recommend you to look at the proposal at least. But well, again, don't take it as something that is like sure. This is only this is only the proposal. So I really don't like to, gaslight you and promise that there will be exemption for your sector. And then we would see that there probably won't be. But my last comment to the exemptions, if any of your uses in like when the restriction will be official, there will be some duties you have to follow if you apply for this for these exceptions. You will have to report to ECHA the identity and the quantity of the substance you placed on the market for this specific uses. So it will not be just derogated, but there will be some follow-ups if you want to take this advantage. I don't know if Jana want to somehow comment on this, or if I hope I managed to
I
answer.
just have turned on. Yeah, I think you answered perfectly as much as we know now, because we cannot really promise that there will be exemption for sure, even though some exemption would totally make sense for us. It can happen that some substances will be restricted, but I think this Lucia's answer also answers one of questions that I can see in the Q&A. From anonymous attendee, for the EU restriction, will there be a possibility to apply for an unavoidable use exemption, like for example in United States? So I think this is something that how it could work. Unavoidable use exemption is basically when you don't have any other alternative and the use of PFAS is essential for health or for safety or function of society. So all these social economical analyses that are performed, I think they will be they will be also looking into use of PFAS. So most probably there will be some PFAS that will never be 100% banned, but they will be somehow restricted. So as Lucia said, you have to report quantities, for example, or meet some other conditions to use these substances. I hope I didn't make it even more complicated for you now.
Thank you both for answering. I think this is a good time to wrap up. We are already 4 minutes past the announced runtime of the webinar, and I think this is the good time to make some ending remarks. First of all, thanks to Mary, Lucia, and Jana for being here with me to provide their speeches. Feel free to join for the webinar in 2 weeks, where we will talk more on use cases and practical advice on how to both go through with the analytics with Measurlabs, or how usually the cases go in the regulatory perspective. If you would like to add anything, Jana, Lucia, Mary, now is the best time to do so. If not,
thank you for joining us, and join our next webinar. We're looking forward for all the discussions. Feel free to contact us all. Thank you.
And if I may, there's a forms link in the chat. If you fill it, you're the best. It helps us make the best events possible. And I'm sorry, I think I cut you off, Mary. I'm very sorry.
No problem, and I want to thank you, all of the participants, and hope to see you in the next webinar.
Okay. Thank you guys a lot. Good luck and see you around.